Hi children, welcome to my YouTube channel. Today we are going to learn a new topic, the Pythagoras Theorem. The Pythagoras Theorem states about relationship between the lengths in a right angle triangle. When you get a right angle triangle, initially we can understand that we can label the three sides in three different names: hypotenuse, adjacent and opposite. In this triangle, initially we need to identify what is the hypotenuse. How do you identify what is the hypotenuse? It's very easy. The hypotenuse is the side opposite to the right angle triangle. So if you just draw arrow from the right angle triangle, you can identify the hypotenuse. In a right angle triangle, we can say if you square the length of the hypotenuse, that is similar to the addition of the square of the other two sides. That is what the Pythagoras theorem says. That means if you get the length of the hypotenuse and we square it, then we get the length of the other two sides and we square them, and if you add the square of the other two sides, that is similar to the square of the hypotenuse side. That is what you mean by the Pythagoras theorem in another way. Let's try to understand the theory what we have learned from this example. Our question is to find the length of the side AB in the triangle. So in this triangle, it's already given. It has already mentioned as the length of AC is 12 and the length of BC is 5. But in our problem, we need to find the length of AB. How do we find it? First, we have to understand that whether this triangle is right angle triangle. Yes, it's as mentioned in the diagram. It's a right angle triangle. How do you identify a right angle triangle? If one angle is 90 degrees, we can call it is as a right angle triangle. Then, to apply the Pythagoras theorem, we need to identify clearly what is the hypotenuse. How do you identify the hypotenuse? What you need to do is you have to draw an arrow from the right angle triangle towards the triangle, towards the sides. With that, you can understand that simply AB would be the hypotenuse. Identify the hypotenuse is very important because the Pythagoras theorem says the square of the length of the hypotenuse is equals to the addition of the square of the other two sides. With that, you can say AB squared, that is the square of the hypotenuse, is equals to AC squared plus BC squared. Then we know the length of AC, it's 12, therefore you can write that is AC squared is 12 squared. And we know the length of BC is 5, therefore you can write BC squared is 5 squared. With that you can write AB squared is equals to 12 squared plus 5 squared. We know 12 squared is 144 and BC is 5, 5 squared is 25. With that, if you add them, you get the answer AB squared is 169. To find the length of AB, we need to find the square root of 169. That turns into 13. Okay children, in this question also we need to find the length of PQ. Here, initially we have to understand whether this triangle is a right angle triangle. Yes, according to the diagram, it is a right angle triangle. With that, we need to identify what is the hypotenuse. Hypotenuse is the side opposite to the right angle or the longer side. So from one way we can say it's a longer side as well. So with that, we can understand that PQ is the hypotenuse. Therefore, if you apply the Pythagoras theorem, you can say PQ squared is equals to PR squared plus RQ squared. So you cannot interchange these terms. Definitely to understand that square of the hypotenuse squared is the term similar to the sum of the length of the square of the length of the other two sides. Therefore, you can write PQ squared is equals to 8 squared plus 4 squared, that is 64 plus 16, 80. PQ squared is 80. With that, you can say PQ is square root of 80. If you find the square root of 80, the third form of the answer is 4 root 5 and the length become 8.94. In this question, we need to find the length of AC. Initially, we can understand that the triangle is a right triangle. Therefore, to find the length of that side, we can apply the Pythagoras theorem because we know the length of the other two sides. Then the next objective is to find the hypotenuse. For this triangle, the hypotenuse is the longest side, the length of AB, or the side opposite to the right angle. With that you can say hypotenuse is AB. Therefore, you can apply the Pythagoras theorem and say AB squared is equals to AC squared plus BC squared. With that, the length of AB is given, that is 10. Therefore, 10 squared is equals to AC squared, where that is the fact we need to find it, plus BC squared, that is 6 squared. 10 squared is 100 and AC squared plus B6 squared is 36. If you brought 36 to other side, turn up into AC squared is equals to 64. Therefore, AC is square root of 64. We know that square root of 64 would be 8. There, with that you can say the length of side AC is 8 units. Sometimes if they are given in centimeters, these lengths, you can say it's 8 centimeters, or if it is in meters, you can say it's meters because the unit value is 8. The figure is 8, sorry. The unit value you have to find according to the question. Refer to this diagram, we need to find the length of BC. That is what they ask in the question. So, to apply Pythagoras theorem, we should know whether this triangle is a right angle triangle. Yes, the side ACB is right angle, therefore this is a right angle triangle. Then the next objective is to identify the hypotenuse. According to this problem, AB would be the hypotenuse, the longest side, where the length is 25. Therefore, you can say AB squared is equals to AC squared plus BC squared. AB is 25, that is 25 squared is equals to 24 squared plus BC squared. Then 25 squared is 625. 24 squared is 576 plus BC squared. With that, if you simplify, you will obtain the answer for BC squared is 49. Therefore, you can say BC is the square root of 49 and you can obtain the answer as 7. Pythagoras triples. Pythagoras triple is a combination of length between three sides which satisfy the Pythagoras theorem. These figures you can fix into a right angle triangle without doing further calculation. Therefore, you can easily, if you remember these values, you can put into the right angle triangle without doing further calculation. You can obtain the answers for the length of the missing side. One example is 3, 4 and 5. When you apply into this Pythagoras triple, you have to understand that always you have to get the longer side as the hypotenuse side. Therefore, you can say from this relationship 3, 4 and 5, we know that 3 squared is 9 and 4 squared is 16. If you add 9 plus 16, that is 25. That is exactly similar to 5 squared. Therefore, 3, 4, 5 is a Pythagoras triple which satisfy the Pythagoras theorem, whereas 5 is the hypotenuse and 3 and 4 would be the other two sides, right? Then another example. If you get 5, 12 and 13, you have to understand that if 5 and 12 are the other two sides, the length of the hypotenuse become 30. 8, 5, 8, 15, 17. Whereas 8 is one side and 5 is the next side, whereas then the 17 would be the hypotenuse. Therefore, always this longer side comes to the hypotenuse. So, in that case, you can apply this Pythagoras triple and you can obtain the answers very easily as well. There is another relationship which is coming with the Pythagoras triple, means if the relationship ABC satisfy the Pythagoras triple, if you multiply this entire length by a constant figure, that combination also follows up the Pythagoras triple. For example, if you get 3, 4, 5 is a Pythagoras triple, we can simply say if you multiply 3, 4, 5 with a constant value of 2, that means 6, 8 and 10. That one also follows up the Pythagoras triple. If you get another example, if I get, we know that 5, 12, 13 is a Pythagoras triple. No? So if you multiply each number by 3, that means 15, 36 and 39. That one also follows up a Pythagoras triple. That is a simple relationship. Here I have mentioned in the red color the most Pythagoras triples where we use in our day-to-day life, and the other ones are the usually common figures where we use as Pythagoras triples, right? In this question, they ask to find the length of side BC. Then the given informations are for this right angle triangle ABC, hypotenuse is 13 and BC is 5. We need to find the other side. With that, you can simply say 13, 5 related to the Pythagoras triple of 13, 5 and 12. Whereas 13 is the hypotenuse. So here it's exactly matching the 13 to the hypotenuse and 5. Whereas we need to find the other side. Therefore, you can simply say 12 would be the length of AC without doing further calculation. So that is how we can use the Pythagoras triples for a question in our day-to-day life. Hope you have understood the contents in this video. If you like this video, put a thumbs up and share this video with your friends. To see more educational videos, please subscribe my channel and click on the bell icon.